Ladies and gentlemen, today shall be with first principle. Now we are given a function 2x squared plus 5, and this is the curve of the function, whereby we have 2 points on it. We have the point P and the point Q, which are connected together, and also we have a tangent of P. A tangent of P. Now this is explaining. I drew this in limits, but actually I didn't go too deep because I didn't want to jump into first principle. Pardon me. Okay. So now let's now assume I have a first y value. Okay. Okay. Now I explained this in our first class. That's under limit. Now the first value on my x-axis, this is my x-axis, and this is my y-axis. And the first value on my x-axis is this. Here I have my this, and here I have my y. Here I have my y1. Then I said, if I'm in the last class I used the marker for instance. Now if my marker was sold for 100 naira and now it is 150. Now what happens to the price? There's an increase in the price. What's the change in the price? The change in price there is 50 naira. That is the present price minus the previous price. So if I'm to definitely this place is the change in my x, and this part is the change in my y. So on my x-axis, everything on my x-axis definitely would be what? From here to here is my x, and from here is my change in x. I'll be having change plus change in x. That's my x1. And for my y1, then this is my y. That's from here to here is my y. So for my y1, I'll be having y plus change in y. I hope this is clear. My x1 will be what? X plus change in x, and my y1 will be what? Y plus what? Plus my change in y. So now moving on, the first principle is actually the principle. The axis is the foundational, the basic principle in solving or in differentiating, finding differentiation of any what value. Now the question is now this. The question is this. Continue. Now the question is, where do dy dx comes in? In the first class of this class, I said my delta y delta x is not equal to dy dx. They are very different. Yes, they are very, very different. And I explained this to be the limit. So dy ds is actually the limit when delta s tends to be 0. That's when it will become dy ds. So once change in y and divided by change in s is not, once the s change in s is not tending to 0 yet, it will still remain this. So until we limit change in s to tend to be 0, that's when change in y divided by change in s becomes dy ds. The reason I'm saying this is because I want to bring the dy ds into this graph now. I want to introduce it. Now, okay, that is the tangent. Now, let us elongate this, so we can get to understand what I'm trying to talk about. Okay, so let's elongate this also. This is a right angle triangle. So from here to here is change in y. Then from here to here is change in x. Here is change in y. Then how about from here to here? This is my what? Dx. Then from here the tangent can continue to any point. So to any point it gets to becomes my dy. Now I will tell you the reason how this became dx and how this became dy. Now it is just as simple as it is. Now how did it happen? It happened this way. Now I would like you to be attentive at this stage. I would like you to be attentive. So my x1 becomes x plus change in x. I would like you to be attentive at this point. Now in our last class under limit, I drew this thing. Then I now said if this thing is to move clockwise, that is, let Q approach P. If Q is to approach P, it will walk down this curve, right? So walking down is gets here, right? Walking down against gets here. So let's now assume it's walk down, it gets to Q0. Walks down, it gets to Q1. Walks down, it gets to what? Q2. If then I didn't let it get to P because I was only talking about limits at that stage. But now that at first principle, how do we get dy dx? Now you now find out as it is walking down, whereby the fulcrum is at P. What happens? My change in y, my change in y was like this, was from here. But now it has reduced to this, then later to this, then later to this. My change in y is reducing. My change in y is reducing. Check my change in s too. It was here, then later here, then later here. My change in x is also what? Reducing. I don't know if you can understand what I'm trying to say. If you are to check it very well, my change in y is dropping. It's coming down, reducing as it is moving. I don't know if you can. Okay, let me zoom out the object, the image. Now I have something like this, and I have this. Now I have this. Sorry. Now I had this. Now I have this. Now I have this. Now I have this. See, I now have this. Now this is now point P. This is my point Q. It is walking down. It is coming down. What happens? It gets to Q0, Q1, Q2. So as it is coming down, my change in y is also reducing. My y came down to this. Now my y came down. My change in y came to this. My change in y came to my change in y became 0. At this point, my change in y equals to 0. Let's check for my change in x too. It was here and now reduced to this. Now here till it became what? 0. My change in x also here is 0. And the point is now, whenever we limit change in x to become 0, when we have change in y divided by change in x, then it becomes dy dx. That's the reason this is dy, this is dx, and this is dy. That's because we've limited them. You see, this curve, this triangle now, this slope is taken from this tangent. That is, tangent is a point whereby the line is not penetrating the curve. It's not penetrating the curve at all, but at the same time touching the curve. That's point P. That's for this line. I don't know if you understand what I'm trying to say here. That's for this line. It's not touching the curve, and sometimes it's not penetrating. So definitely both change in y and change in x, they are now 0. And once they become 0, what happens? It becomes, we have a gradient called what? Dy dx. So as change in x approaches 0 and change in y approaches 0, then I will now say what? The gradient of the curve PQ becomes dy dx. That's just it. So that's what brought about the limit of dy dx, change in y over change in x becoming dy dx. And for the change in y, you can use it. Last I said change in y is actually, this change is actually a Greek letter for d. So in English it is d. And the capital letter in Greek is this small triangle, something like this, delta. And in English it is like this. I differentiated this, but just that I'm used to this than this. So that's the reason I'm using it. So if you know this is not comfortable, you can use it to change in x tends to be 0 and change in y tends to be 0. Still the same thing. So as for this, you can say limits change delta x to be 0 in whereby delta y delta x will be equal to dy dx. They are still the same thing, whichever one you think is more comfortable for you to use. So that's that about this. So I hope limit is now clear, and the reason why when you limit delta x equals to 0, delta y divided by delta x becomes dy dx. This is actually the reason. So that's clear. And now let's now come to our first principle. Now for our first principle, we are actually using this also, and that's the reason I do this in the first place. Now I said my x1 became what? X plus change in x, and my y1 became y plus change in y. We're actually be using the same question to explain that. So y is equal to 2x squared plus 5. So since my x1 equals to x plus change in x, and my y1 equals to y plus change in y, so definitely we can say since x1 is equal to x plus change and my y1 is equal to x plus change in 1, in what's it called, in coordinate geometry, to say my slope is equal to y2 minus y1 all over x2 minus x1. This same thing is also equal to x minus x1 all over, sorry, not x at the top, x1 minus x over y1 minus y. I can have it. So definitely in this, what am I writing? This thing is also equal to y1 minus y over x1 minus x. They are still the same thing. So actually I can say in this place my y is replacing my y1, and here in this place then my x is replacing my x1. I hope that is clear. As well, I can also say my slope is equal, whichever way you can say your y minus y naught over x minus x naught, whichever way you put it, that doesn't matter. What matters is just make sure the higher is reducing, is subtracting, the smaller is being reduced, is being subtracted from the higher one. That is what we're making sure here. So same thing here, we can also say my make x equals to x plus delta x, and my y equals to y plus delta y. And why is it like this? It is only explaining that wherever we see x inside any given function, we replace it with this, and wherever we see y in any given function, we replace it with this. Now there are actually rules for solving using first principle. If you can follow these rules diligently, the first principle becomes so easy for you to solve. So now the first rule number one substitute y for y plus delta y and x for x plus delta x in the given function. So I can now say my y plus delta y equals to 2 into bracket s plus delta s all squared plus 5. I hope this is clear. Y became y plus delta y, then my x here became my s plus delta x all squared. So now continue. The next one is we're going to simplify this place. So my y plus delta y equals to 2 into bracket s plus delta s. Since it's square, it will be in two places. So plus 5. So my y plus delta y equals to 2. Here I'll be having s squared plus s delta s plus s delta s plus delta s all squared plus delta s all squared plus 5. So I can have my y plus delta y equals to 2 into bracket s squared. S delta x plus s delta s is equal to 2s delta s. Mind you, don't do the mistake. S delta x is not the same thing as delta x squared. Delta s squared, you are actually telling me delta times s squared. But this is telling me x, s delta s, delta s squared is actually telling me this. But s delta s is telling me x times delta s. And mind delta s is an entity on its own. So you can't separate them. So that's using it has to be written in this form and not in this form. So that's that about that. So now s delta s plus x delta s gives us 2x delta s. So I still have my plus delta s squared, delta x all squared. When I have delta x all squared, it is equal to the 2x. Yes, it is equal to what? The 2x. Just like when we have sine theta all squared, we will say it is equal to what? Sine squared theta. So that's just it. So even if it is cubed, it will be the 3 what? The 3x. So that's that. So let's replace it. So I will have the 2x. So I have this plus 5. So now my y plus delta y. Let's open the bracket. I have 2x squared plus 4x delta s plus 2d2x plus 5. Now we have 2. Now rule number 2. Rule 2 now says make delta y the subject of the formula. So meaning my y will move there, right? Of the formula and substitute y value in the function. So first of all, it says make the y set of formula, meaning we transfer y here to make delta y set of formula. So I can have my delta y equals to 2x squared plus 4x delta x plus 2 delta 2x plus y. If this counts, becomes minus y. The next thing I said, and substitute y value. From my function, y is equal to 2x squared plus 5. So I'll substitute it here by saying my delta y equals 2x squared plus 4x delta x plus 2 delta x plus 5 minus, what's my y? My y is 2x squared plus 5. So I can now have my delta y equals to 2x squared plus 4x delta x plus 2 the 2x plus 5 minus times this is minus 2x squared minus times plus 5 is equal to minus 5. Now let's check if we can cut. Plus 2x minus 2x squared removes each other. 5 plus 5 minus 5. So what do we have left? My delta y will be equal to 4x delta x plus 2 delta 2x. We have reduced it now. So the next thing is now rule number 3. It says divide both sides by delta s. You know, previously we have delta y equals to 4x delta s plus 2d2x. So now the way we divide, once we apply this rule, it becomes then by delta x. Okay, let me not apply it directly so it will be easy to understand. Okay, so once I apply this rule, it will become 1 over delta x into brackets delta y equals to 1 over delta x. So I get 4x delta x plus 2d2x. So we're having here we're having the y over delta x equals to here we're having 4x delta x over delta x plus 2d2x over delta x. So this removes this. This square is being cancelled as this will cancel one of the dx. So that will be left to dy dx equals to 4x plus 2 delta x. So now find the limits. Now say limit delta x to be 0 both sides, and that's the third rule. That's the fourth rule. So let me apply it to rule number 4. States that find the limit of both sides where delta s approaches 0. So and that's the limit delta s to be 0 on the left hand side first, then on the right hand side 4x plus 2 delta s. So once we limit delta y delta s, it becomes dy dx. So here simply means anywhere we see delta x we put 0. Now having 4x plus 2 into bracket 0. So dy dx equals to 4x plus 0. So finally my dy dx equals to 4x. And that's our final answer for this question. So that's just the way of using first. Those are the 4 basic rules of using first principle to find solution to any problem, or finding the first derivative for a problem. So that's that about first principle. So we shall meet in the next class, hopefully. So well, stay tuned to our channel. And anywhere you find challenges in mathematics, physics, then just comment it below, then we'll attend to it. Thank you very much. Thanks for watching. Don't forget to subscribe to this channel. Just the Fike Maths, like, share with your friends, and also comment below your view about it. So thank you very much. Thanks for watching us.